tonight's. So everyone, we're just going to start the recording, which will be great. So welcome to tonight's session. Very pleased to have our guest presenter here, Graeme Anderson. Tonight's topic, looking at local climate history and future climate drivers for our area. And Graeme's a climate specialist from AgVic. He's a team leader of the climate team. So helps to deliver, members of Graeme's team help to deliver a lot of the resources that I share in my newsletter frequently. So things like the very fast break videos, the newsletters around seasonal variability, the soil moisture probe information that we ran in a webinar back in December. So there's a whole host of great resources that come out of Graeme's team. And I've been fortunate to hear him talk before, and I know tonight will be really interesting, and thank you for everyone coming on board. So I'm going to hand over to Graeme. Now, we've got a very casual format for tonight. Now, as this is a webinar, there is a Q&A button down the bottom of the screen. And if people have questions about particular slides as Graeme's moving through this, please submit them via the Q&A function, and I'll moderate those questions. And if we can answer them then and there with Graeme, I'll pop in with that question and ask him. And if they're a more general query, I'll save them to the end, and we'll have a bit of a session at the end where we can allow people to come forward with any questions that they've got. So I might hand over to you. Thank you, Graeme. I can see your overheads up here, so I'm going to pop myself on mute. But if you need me, I'm just at the other end of the computer.
Very good. Thank you. Thanks, Sally. And thanks for all of your organising, and welcome everybody tonight in that lovely part of the world in the Greta Valley. Now, and I hear it's all still green up that way. It's the spring that's kept going. So tonight, a bit of an overview of climate drivers, and hopefully it'll make a bit of sense. Just as Sally was saying, lead our climate extension team members. So some of you might know Dale Gray and the Break newsletter, which is really all of those seasonal forecasting updates. And then there's another Dale Boyd with the soil moisture probes network across the state. And we run climate webinars and all sorts of things like this. So often a lot of local talks where we'll drag out 120-year rainfall record and talk about what's been behind the wet years and dry years, which is exactly what we're doing tonight. I'll give a bit of a plug just for a few other things that we have on the go within AgVic. We have a regular webinar series for anyone interested in climate-related issues, and always up for any good examples or good speakers that people have heard about. But we've got one actually tomorrow featuring some Northeast story on climate and adaptation workshops, which were done with the dairy industry. So if you want to track that down, that's a lunchtime webinar. We normally have those lunchtime webinars once every month or two. So you can subscribe to those and be informed of when they're coming. There's some past ones as well, webinars, which are a bit like your format tonight, Sally. They're recorded, and for people that are busy, but if there's a topic they wanted to get to the bottom of, there's a few there that are just sitting there as recordings. Also the Break newsletters, which I understand a few of you already get, and that's in a few formats. We've got Dale Gray with the YouTube, monthly YouTube versions, but also his e-newsletter, which is a pretty good bit of work. And this little table down the right here, I'll explain it. It's a pretty important bit of work Dale does here. Every month, he looks at about 12 global forecast models that basically, to do any seasonal forecasts, all of the world's forecasters have to do a model of the whole planet, not just their sort of country. And so Dale sneaks a preview of all of those models and then looks at the little bit of Victoria on their map to see how many of them are showing wetter, drier, or they're split across the camp. So it's not a bad sort of form guide sometimes to watch. And Dale and I we pay more attention when usually more than half of them are sitting on either the wetter or drier, and they're starting to do that. But that's the current outlook at the minute. So there's still plenty of moisture around, and we'll talk a bit more about forecasts a bit later on. Soil moisture probe. So I think you've also heard there's a soil moisture probes under both crops and pastures that are just some test locations around the place, and really interesting to see how and where they tell you something that you can't see from the top of the paddock. And there's one in at Greta too, or a couple of probes there. And interesting to tap into those. So they're all live, so you can see it, and they're all pretty full at the minute, which is obvious from all that storm you've had. But they can play a useful role, especially when it comes to an early spring and dry year. Sometimes things look green on top, but some of the soil moisture probes can show that, you know what, there's rain in the bank, or the soil moisture probe might be only half full soil profile, which means the spring could be a bit quicker. So just different parts of the state, they're helping us learn a bit more about the rainfall versus how much is stored in that soil and how quick the plants are using it. So webinars, the newsletters, just head to our website, agriculture.vic.gov.au climate risk. And there's also some podcasts there for those that are into podcasts and got plenty of hours on tractor or long drives. You can listen to a few different articles trying to explain and interview different people talking about climate. Another little thing I'd give a plug to is the Bureau of Meteorology. Of course, they're the home of all of the key climate work that's happening across the country. They produced some climate guides 2 years ago, I think. And so these regional climate guides are not a bad start. And there's one specifically for the Northeast Victoria that just sort of covers the region, usually looks at sort of the previous 30 years of weather indicators and compares that to the prior 30 years. So it goes back sort of 60 years to just say, well, what's normal, what's different, what's up and what's down. So it's a good little brochure. You can get those climate guides at the website link that's there. Just as a quick overview of the region, you're still, pretty reliable rainfall, still dominant winter rainfall, but there's a little bit of a mix happening there, a bit drier in springs and autumns. There's been a few more spring frosts in some areas and a few more hot days in a quick summary. So this is in the guide, and I'll go through this pretty quickly because we've got the local rainfall record we'll get into, but this is just an example of what's in that climate guide, Corryong and Wangaratta, and the red is the more recent 30 years of rainfall. How does that compare to the dark colours, which is the previous 30 years to that? And so some good information in there. The frost issue is an interesting one because I know one of the things that's been a bit of an issue probably since the millennium drought is just some of those warmer or drier springs, and it might be warmer during the day, but clear, dry nights can actually be a bit frost prone. So in some places like this is Rutherglen here, you can see the red is just showing the last 30 years has been a few more frosts in some of that spring period. And of course, a few more warmer days, I guess, as when we'll talk a little bit more about that as well. So days over 38 or over 40 on the way up. There always has been hot days in our record. It's just about how many, and we'll talk about what's going on there. So I'll give a plug too to this little tool, the Climate app. You can have it as an app on an iPad or a phone, or you can look at it on the desktop. But it's a good little tool for farmers, and you can see all of these dots here. They're long-term rainfall records. So you can normally pick a site that's not too far from where you are. It's got a pretty good history. I've just clicked on it and downloaded the data from Hansonville, which is just up the road. And you can do things like, track the season's progress of rainfall. So when you do it for Hansonville, and this is sort of like for every 12 months, all of these blue lines here are past years and past rainfall histories. And then the dark line is the long-term average, and the red line here is just how you're tracking already. So, which is showing that yes, January was pretty wet in your part of the world. But will it sustain that? Quite often, summer rainfall and autumn rainfall doesn't really have a lot of bearing on what's going to be happening down at the business end of the year next year. Later this year. It's a handy little tool because you can also go back further. This is looking at the previous 5 years or 60 months, and you can sort of see a bit of a dry spell there. We were running out of rainfall there, especially with 2019. 2020 sort of held its own, and then 21 helped a bit, and we're almost getting back there. So you can sort of set whatever time periods you like here with the Climate app. There's also a great little feature on it called How Often. So someone would say, gee, we've had 100 millimetres of rainfall in January. That is incredibly rare. Well, you can use this to say, well, how often have we had more than 100 mil over a 30-day period in January in that record. And it'll look it up and it'll say, well, Graeme, we've actually had that happen in 12% of years. So it's happened before, and it shows you sort of where those years were. So you can sort of, it's not a bad guide because it just helps you check often. And I'll get to autumn breaks because often we're very anticipating autumn breaks, and we love getting early autumn breaks, but sometimes trying to work out what we want versus what normally happens in this district. The climate app's a good way just to help get you thinking sort of your barometer in the right frame of mind. So here's one where you can say rainfall, how often do we get more than 50 millimetres or 2 inches in the old scale, say over a 10-day period in that Hansonville record in the months of March and April, for those that like to get away the season early. And it says, well, for that query, in almost 50% of years, 49% of years, we would get 50 mil over 10 days in March or April, and it goes through when those years were. So in pretty reliable rainfall country you are. So here we've got a long-term rainfall record, and I'll just explain what it is. It's from now. So how do you explain, is it Moihu? There's always a local way of saying
it. It's Moihu. Moihu.
Thank you very much, Moihu. There's always a risk, and someone from Geelong would get this wrong, so thank you, Moihu. So the rainfall record here goes back to 1901, and you can see along the bottom here, 1901, 1940s, goes through each decade up to 2021. And up the side here is millimetres. So you can sort of see 400 millimetres. You can see some years where, it was actually under 400 millimetres. So no doubt there'll be people with stories saying, yes, we remember those years. 2006 would have been one, and back in the 82 drought. But you can see 800 mil, 1,000, over 1,200, some really wet years as well. So what this is just an anomaly where it's just put a line through the long-term average, and which, goes up or down a little bit depending on the run of years. But these blue years are the wetter than average years, and the red ones are drier than average years. So I'm just going to leave that up for a little minute just to have a bit of look at that long-term record. And interesting, I certainly see a lot of these around the state, but, yours is not too bad. In terms of the last 20 years, different parts of the state have had a lot more dry years, but your ratio of, the last 28 that are sort of got the above the line and 12 below the line isn't too bad. One thing I would get you to look for is how often does the rainfall get pretty close to the line, meaning it's pretty close, you've got average rainfall. So just count them up because there's probably not a lot of years there. So we talk about average rainfall a lot, 740 mil there at Moihu. But, we might start January 1 expecting that long-term average, but it's far from guaranteed. You can get anything from less than 400 to over 1,200. So we'll talk about why that is, and is there anything that gives us any indication about how each year might plan out. This next slide just splits that Moihu rainfall record into the seasons. So you can see summer, autumn, winter and spring. So strongly winter dominated. But you'll notice in each of those, I've just done the last 20 years, how many were drier or wetter. Now, can anyone notice a pattern there amongst any of the seasons? Just have a little bit of a look. Lots of variability there, which will continue. But just interested if there's any thoughts or questions around that. And there's one particular season which is a bit different to the other ones.
So someone's jumped in, Graeme, to say that there's more summer rain. So it's not as dry over summer as it has been over autumn, winter and spring. Yeah, that's right. So interesting, just looking at those last 20 years, your experience up there that, 8 of the last 2013 have been wetter summers. But for a lot of these other seasons, say autumn's 14 drier and only 6 wetter. So autumn's, you've been a bit of a little shift there. And that sort of 14 drier and 6 wetter is a similar theme in the 20 years for autumns, winters and springs, but summer's getting a bit more. So you've got a pretty generous rainfall, but it's just
which means you've still got plenty and it's a great place to farm, but it's just sometimes that bit of a pattern change that's happening, which we'll talk a little bit more about.
Graeme, I just had another question there. So you're talking very much about averages at the moment, and Kate's just sent in a question to say, do you use graphs based on the median as well, or why do we look at averages and not medians for rainfall?
Good question. I think medians are a really great way to look at it. In fact, as we get into the climate driver stuff, it sort of helps you probably look at rainfall a bit differently, I guess, because part of it is just trying to work out, even if you're talking about, are we looking at a wetter than average year or drier than average? What's the commentary around that? Or are they just guessing and all possibilities are still on the table? And it's really important because sometimes, and I'll get to the definitions of some of that, sometimes people see a forecast that says, we might have, only 50% chance of more than average rainfall this season. And people think, oh, that means average. And actually it doesn't. It means that it's 50% chance of wetter or 50% chance of drier. And I'll explain what sort of sits behind that modeling, that actually decile 1 being really dry through to decile 10 might all be sitting there on the table, that there's just no indication from what they're looking at. So we'll get into that one. So it's a really good question. So beware averages, but I think the median's a good way to look at it. The first key question though tonight, and everyone just to get a pen and have a bit of a guess, see how you go here. What are the 2 key ingredients if you're given the job to make rainfall in the Greater Valley? There are 2 essential ingredients that make rain, and so we've got to get these 2 out before we can progress any further. So I'll give people a little bit of time to think about that, and they're happy to throw something in the chat. But without one particular ingredient, we can't make any rain at all. What is it?
I'm guessing one has to be moisture, doesn't it?
Thank you. Yes, very good, Sally. And moisture is a really critical ingredient. So if you've got dry air, you cannot get rain out of dry air. So this next slide shows where in the world you can see world precipitable water. And so the legend here is, this is satellite imagery, but it's showing the precipitable millimeters or kilograms per cubic meter of water that sits in the air. So basically really humid air. And where do you notice most of it sort of sits? Well, it sort of sits over the oceans and along the equator. So that's sort of the key driver. It's the warmest part of the planet. It's where our sea surface temperatures are the warmest. There's heaps of steam. The water's really thick. The air is really thick, holding lots of water. So what's really important some years, and you can sort of see this here at the minute, out here in the Pacific Ocean, it's really important driver, and along the equator, all of the seasonal forecasters look at what's happening along this equator, and they're all trying to guess where is most of the moisture going to stack up. And with the current La Nina that's on the way, there's cooler water out here, warmer water over this way, and that tends to generate more of the moisture. So that's basically the La Nina you can sort of see there with extra moisture over our part of the world. And the Ocean Dipole too, it has its sort of moods. There's sort of always usually moisture along the equator, but sometimes a lot more of the moisture in those wetter seasons are when the moisture is stacking up to our north. And what that means is when we have weather events that come whizzing along, if they can tap into that moisture supply, then that's a year we're more likely to have good rainfalls. And so some years, all of that moisture sitting somewhere else, and that makes it very hard. You can have weather events trying their best, but they're just not bringing the moisture that we'd like. So that's one key bit. You got to have moisture. And the other key one is if all we had was moisture, we just have really humid air. So something actually has to make it fall out. And so what we sort of see, and the typical example I use just up here is if you have, nice moist air coming in off the ocean, when it gets lifted up, as you go up and, as you drive up to the top of the Alps, things get colder. So the atmosphere gets colder. So when you lift really humid air up, it gets colder, and then it basically means the water can't be as water vapor anymore. It falls out as rainfall. So it's got to be lifted up. And it's interesting that sometimes, depending on what side of the range or the hill you're on, if you're on the side which the moisture is coming from, you can have rain there. But on the other side of a range, as air's coming down, it's getting warmer as it comes down, and it can hold more moisture, which means it doesn't want to give up its rain. So it's really that uplift which creates the rain. And you can see over here is sort of the action of a cold front. When we have those cold fronts from the west sweeping through, they basically work to push up moisture. And when that gets pushed up, if there's a moisture feed coming in, then it falls out as rain. So that's it. So when you look at the sort of alpine range there, you can sort of see different weather events when they come through, you know, and when you can track into some good moisture coming from the north, that's when you can have some really big events. And you might notice sometimes East Gippsland can sometimes be on the other side of that. If they're getting a wet year, sometimes they're having east coast lows and things that are bringing in moisture from this side, which means they get a bit more their side of the range. It usually all still falls on the top of the range, so you get good catchment, but sometimes, you know, one side or the other can be missing out depending on that direction of the weather flow. So those two key ingredients, got to have moisture, and then you've got to have something to make it fall out. So I like this particular diagram. It's 3 different satellite images that it's been stitched up, but you can see the southern hemisphere. This is sort of Antarctica. You can see Australia and our little part of the world here. And the big drivers that are driving, you know, those seasons that make it wetter here really form quite a long way from us. And so you've probably heard of the El Nino Southern Oscillation, which has El Nino when it's at its drier scale and La Nina when it's at its sort of wetter end, like it has been for the previous few months. It's just basically the big variable out here in the Pacific Ocean, and the trade winds blow towards Australia. They're bringing moist tropical air, but a La Nina, it actually brings extra tropical air and stronger trade winds. And in El Nino, those dry years, all the moisture is sort of sitting out further in the Pacific Ocean, and the winds sometimes even go backwards, which means very hard for us to get rainfall in Eastern Australia when it's decided not to play ball. The Indian Ocean Dipole, which I know a lot of farmers have heard about too, and it popped into its wetter phase last winter in sort of July, August. And, you know, sometimes when the warmer water's up here and there's extra cloud around Sumatra, it's a great feed-in for moisture that ends up, you know, hitting these cold triggers down south. And you'll note these cold triggers, the roaring 40s, the winds that whiz around the Southern Ocean. There they are, the Southern Annular Mode. They drive all of these. It's like the conveyor belt for all of these cold fronts that flick their tails across Southern Australia. Now, if the Australian continent was sitting, you know, a lot further south, you know, there'd be a lot more rainfall further inland because, you know, of these disturbances that happen, you know, above our heads because of this atmospheric disturbance. So these are really important because this is the cold air that is creating the disturbances for us, and they sweep through. There's usually one a week. And then years where there's more moisture supply, then they can fall out more rain. So they all have a bit of an act to play, and that they're all got their fingers on our wetter or dry years. So this next bit, and you probably might have seen some of these in the very fast break, these are sea surface temperature maps, which the forecasters watch like a hawk pretty much along the equator to see what's going on. Now, these colours here, blue is sort of showing cooler than average water temperatures, and this is showing warmer than average temperatures of the orange. Now, I'll just explain, normally along the equator, the water is really warm, like a warm bath, and down here swimming south of Geelong, it's pretty cold. But this is showing anomalies, just where areas of ocean might be warmer or cooler than it is normally. So this is showing a drier pattern. So it's back to the drought pattern of 2006, and El Nino in the Pacific. So extra warm water over here off South America. It's creating more cloud, and that's dragging the trade winds backwards. And you'll notice to our north, we've got cooler than average water, which isn't generating as much moisture. So what would happen in that situation if we did that satellite imagery of precipitable water, you would see most of the moisture is heading over here. And the same in the Indian Ocean, most of that sort of extra precipitable moisture would be sitting over towards the African side. So these are some of the things that the forecasters look to and see, you know, are there any signals in the coming winter, spring? This is the 2010 sort of wet spring and summer, and you can just see the difference here between these two. Like this is the big La Nina here, the trade winds are blowing stronger, all the warmest waters to our north, rich with cloud, and then it was just a matter of really, you know, the pre-seasons got plenty of moisture that's coming our way. What they don't know beyond the 7-day forecast is exactly whose farm is that going to fall on, because it's a weather event that delivers it to the farm. But the seasonal precondition is about, well, how these climate drivers are set up to either be sending more moisture for the next 3 months, and if the right weather system drops it, it'll drop it on your farm. So that's sort of how that the forecasts created. We're just looking back at history too, that Moyu rainfall record that we've got. This is just looking at how that's compared for the different climate drivers. So this is looking at the August to October, I think. I'm having trouble seeing that on my bar, my slide at the minute.
Yep,
but
August to November rainfall you've got there.
Thank you. Thank you very much, Sally. So, and if you look at the previous times there's been an El Nino year, this is what has happened. So normally in that Moyu record for that rainfall, you'd expect a third of years to be wetter, a third drier, and a third average. But when you just go and you say, well, let's look at the El Nino years, what was rainfall like in your district in that Moyu record? 3/4 of those August, Octobers were dry. And there was obviously a wet season or two that did pop in. That was an El Nino year, but it's a really strong driver to a drier sort of winter, spring in your part of the world. And similar to when the Indian Ocean Dipole, when it's having its drier phase and it's turned off that moisture supply, really changes or doubles the chance of a drier spring. So these are the sort of things, and that's what's done in the past. It doesn't guarantee a dry spring, but it doubles the chance. And occasionally you have years where these two combine, and that's sort of where our bigger droughts are. The 06 and the 82 droughts are when both an El Nino teamed up with a dry Indian Ocean Dipole, and it sort of meant, gee, it's really hard to get moisture because both of them aren't behaving. So they both influence our seasons. And then when you see them on the wetter side, the La Nina increases chance of wetter. It doesn't guarantee it by any means. Still 1 in 5 La Ninas were dry. And then here's the IOD negative when it's in its wetter phase, and it's probably got a little bit more stronger correlation in your part. The next slide is just, and again, I think Dale Gray's crunched this for us. This is just looking at inflows in the 15 Mile Creek at Greta South. Again, just looking at the inflows when there's an El Nino year. So again, normally you'd expect a third of these to be red, a third of them lower years, a third average, and a third higher. But you can just see strong chance of a lot less runoff in those El Nino and when the Indian Ocean Dipole's in its dry phase, IOD positive. And the La Nina, probably not as strong an impact there, but this is, we see this a few bits, especially in Western Victoria, that when the Indian Ocean Dipole's in its wetter phase, really strong driver towards wetter or average. It actually hasn't been a low flow season there whenever there's been an IOD in its wet phase. So there you go. They're a long way away, these climate drivers, and they change the odds. Their fingerprints are over our past seasons. The big question is, can we tell what they're going to do each year? This is another little tool that if anyone wants to have a look at, it's a local climate tool with a project we did with GRDC, where we've got a few rainfall sites across the GRDC southern region, and we just went back and categorized all of the previous seasons into which ones were El Nino, La Nina, negative or positive IOD, or which ones were combos. And so so you can sort of see there's some of those bigger droughts, dry years are often where there's an El Nino and an IOD dry phase together. So, but not always, but pretty often it skews the odds. So that's sort of setting the scene, I guess, for those big climate drivers. And then we sort of get into this story of what's going on with forecasting. And I just thought I'll explain a little bit, because we're used to watching forecasts and our weather forecasts, which talk a certain language, but the language changes depending on the time period we're talking about. And weather forecasts are pretty good. I mean, 40 years ago, if you had a 3-day forecast, we were pretty pleased, but now they're sort of out to 7 or 8. And there is a bit of a limit. You sort of get pretty scratchy beyond day 8 or 9 for forecasts. And they can generally pick a weather event coming. Sometimes the models are really uncertain about some events, and especially thunderstorms. They can predict when it's likely to be thunderstormy weather, but they cannot predict where the actual thunderstorm will happen. And so and often, as we know, with thunderstorms, it might only be you might only get an hour's notice when you can see one that's formed and it's starting to track. So that's thunderstorms, and some of those big extreme events keep them guessing. And I see a lot of farmers now too look at different forecasts, and it's really important on your phone app to know which weather forecast are you getting, because everyone assumes that every forecast they're looking at on their phone is from the Bureau, but there's quite a lot of models that are out there. And so you might be getting someone else's forecast, which is okay, but you might be comparing with your neighbour. One's expecting 40 mil and the other's not expecting any. And it's because you're looking at two different sources of the forecast model. So it's getting a bit trickier when you're trying to work out, but it's worth asking, whose climate model am I looking at here? One of the things, once you go beyond the weather forecast, we talk about these seasonal forecasts, which is for the next 1 month or 3 months. And really, there's no guarantee of what happens once you go beyond the weather forecast. The models tend to spread out. They're a lot less certain. And what they talk about then is they talk about probabilities of what might have an increased chance of happening, but they really don't know. And they might run 100 model runs, and they'll tell you where they might have fallen. But any one of those model runs could be the right one. They just don't know which one. So we'll talk a little bit about that, because it's important when you're interpreting seasonal forecasts what they can and can't do. And even while they can be useful about when they're lining up saying we're pretty confident there's increased chance of wetter spring, part of it is just understanding, well, why are they saying that? Is that because we've got plenty of moisture in our part of the world and that's what's driving these climate models? And it helps you with your decision making. But just remember, it still takes individual weather events to actually line up and deliver that rain over your farm. So occasionally we miss out, even when there might be a wetter outlook. The other bit is about climate change projections. So when we talk about a lot of climate modelling that's happening over the next sort of 50 years, a common question is often, how do they know if you can only do the weather to 7 days, then what's this talk about the weather or climate at 2050? And it's interesting that probably the scientific confidence around things like increased heat in the coming decades and a poleward shift of our weather patterns towards the poles and increasing rainfall intensity are really high confidence, and they're probably of higher confidence than the 3-month forecast outlook, because they're sort of driven by principles of physics which are playing out and being measured. But one of the things with the climate change is also important about what they can't tell us. And often a lot of the future projections, they give us a general direction in trend, but they don't sometimes give us really important stuff, such as how might things like the El Nino Southern Oscillation or the Indian Ocean Dipole change, or how might some particular weather events change. And weather is the really exciting stuff. But currently some of the climate change models don't probably capture the full extent of some of the potential extremes we might confront. So just thought it's worth covering that sort of range of things. They've all got bits where they're pretty good, but also got bits where we've got to be cautious in what they're saying. I talk about a little new project which is just developing up some new forecasts on seasonal forecasts called Forewarned Forearmed project. And I might have mentioned earlier just about forecasts and what happens if you know, a forecast said, you know, for the next 3 months you've got a 50% chance of above median rainfall. Does that mean, you know, they're expecting that you'll get average rainfall? And what you might have is they've run a bunch of the models and they're really quite split out, and it might mean that actually they're saying everything's possible, all options are on the table. So really important in that situation to say, well, it won't be dry and it won't be wet, because they're saying we've got a 50% chance of either way. Quite often the models are saying, well, it could still be dry, it could be wet. There is just nothing guiding the current forecast. It's really up to, you know, a bunch of other factors. There's no climate driver that's pushing it one way or the other. So often that means from a farming point of view, we've sort of got to have a plan for wet or dry or anything. This is the current seasonal forecast that the Bureau's got, puts it out from, it's just from last week, issued on the 3rd of Feb. And you can see it's modeled for the whole planet. And, you know, these drier chances of less rain is out here where, you know, you can sort of see that La Nina pattern and extra rain over in some of these areas, which is feeding in. So when you look at that and you see this sort of a map where they're saying this is where we think there might be increased chance, it's really representing the model runs of, if they've run 100 model runs, this is where, you know, this color here would be where over 80 of the model runs were wetter than average for the next 3 months. And then this really dry color would be saying, yep, all over, you know, most of them were drier. So you can see a bit of a mixed bag in our part of the world, but still extra moisture expected because of that extra moisture from the La Nina up the east coast. When you hone in on it, and you can click it and get closer, there's a new product that a lot of people probably haven't discovered yet. If you go to just south of Wangaratta and click on it, up pops this little forecast box, which can give you the outlook for February to April. So it converts it into what's the forecast outlook for Greta from February to April. So I'll just expand that up. And basically, you know, that forecast, which was saying, oh, there's a 50% chance above average for the next 3 months. This is decile, this is that sort of the same model runs for the next 3 months, but it's showing you how many of those models landed in decile 1, 2, which is the driest 20% of years, or the wettest 20% of years. But see, actually, at average, what was probably one of the least likely things. So we're sort of saying there's a bit of a skew towards it being wetter, but they're also saying there's a lot of model runs when they let it run out for the next 3 months, showing that you could either get decile 1, 2, 3, 4, or any of them. So that's a really open sort of an outlook where it's not really strong. Sometimes you'll see them quite piled up against the wetter end or quite piled up against the drier end, but this one's a pretty flat looking one with hints of extra moisture around, but it's not a really convincing one, if that's a fair way to put it. So keep an eye out. There's a few more products of that coming, but if you click on that seasonal outlook map, it'll bring it up. I'll just sort of shift a bit here. This is that long-term variability of Australian rainfall for the last 110 years. Blue years are where, you know, there's been extra rainfall, and red's dry. You can see the 2019 drought there. A lot of variability in there, and some big wet periods in the 70s and 10 and 11. But on the right here, we've got maximum temperature deciles. And so blue is cooler than average years, and the orange is warmer than average years, and or warmest on record. And you'll notice that while we've got lots of variability here, there's a bit of a different pattern here where the last few decades has been more often than not been warmer than average, up in the, you know, the top 10% warmest years or warmest on record. And 2021 was interesting because we had it was pretty close to average for our part of the world, which was thanks to all of the cloud and everything we had. So here's Southeast Australia's temperature records, max temps for summer, autumn, winter and spring. A lot of variability in the mix, but you can just see they're all sort of trending up a bit. And spring's been one of those seasons which is probably warming the fastest for a daytime temperature. That you can see here of the last 10 years, there's been 3 that have been sort of average, and that last spring was great. It was a lovely average spring, which the crops and pastures absolutely love. But quite often we've had quite a few springs that have been 1, 2, or even up to almost 3 degrees warmer than average for the whole 3 months of spring. So that's sort of like an extra month of summer. It's come early. So that's one of the things that's sort of a little bit different and gnawing away at our seasons in some years. So that's all part of the climate change pattern. So the scientists expected that, and it's happening. And without greenhouse gases, climate would be pretty static. But this is sort of where we're just starting to head off into these sort of warmer trends each decade. One of the other things I've been noticing about weather systems in Victoria, this is from the Climate Change Report for Victoria. Rainfall from cold fronts and low pressure systems in the cooler half of the year sort of declined a bit, and then thunderstorm-related rainfalls increased in the northern Victoria in the warmest half of the year. So this is warm season rainfall over November to March, and you can sort of see for the last 30 years, we've been getting a bit more of that summer rainfall, which is what you've been living with up there. And it's been at the expense of a bit less in the sort of winter season. So that's a bit of a sharing that with a few others north of the divide. There's also been a bit of an interesting thing with rainfall and catchments, and probably more so to the west of the state, that since the millennium drought, some catchments haven't quite recovered in terms of, when we get X amount of rain, do we still get the same amount of runoff? But the northeast has still been pretty good. So it's just sort of saying sometimes over 20 or 30 years, if you have drier than average more often than not, you can start to drop some water tables a bit, which then stops some of the base flow into some of those creeks. So usually the impact's a bit greater on flatter catchments. So because you've got steeper catchments, you've still got some pretty good rainfall at the minute and runoff. This one I thought I'd throw in, Sally. When we talk about warming up the atmosphere, this is just a graph showing why, in the climate change models, what they expect, there's pretty strong confidence around increased rainfall intensity in future. It's just the sort of laws of physics of how rainfall operates. And this is, imagine this is the center of a thunderstorm, this axis, and this is the distance from the center of the storm. And we're talking about storm bursts and the amount of precipitation and where it falls out. So if you imagine you had a cooler atmosphere or a warmer atmosphere and you've got a thunderstorm, what happens in the warmer atmosphere is the cone of all that moisture feeding in falls into a tighter cone. So if you can imagine this here, the red is the warmer atmosphere. You might have a bit of extra moisture feeding into it, but then it's falling out in a tighter cone compared to this sort of a thunderstorm in a cooler environment. So that's why as you head closer to the equator and the tropics, you get much more intense rainfall and really that sort of behavior. So that's part of what sits behind some of the climate change modeling when they're saying, well, we expect the future to have some more intense rain. It's just that we've not fully captured that in those future weather models. So, and there's a little bit of that, I think, that probably fits into some of the rainfall that farmers have noticed, that they can get some big summer rains, but often it's not, it might be one end of the farm, but it's not at the other end of the farm. But so yeah, rainfall intensity is something that's going to be around. So there's been lots of change that farmers have been dealing with. So I'm going to just round it up here. And this is a bit of work looking at changes in seasonality of rainfall by a guy, David Stevenson, who was just talking about summer dominant rainfalls, uniform rainfall throughout the year, and winter dominant rainfall systems, and sort of just showed, well, how's it changed since 2000 compared to the previous 100 years? And he found most of those climate zones have sort of, well, that seasonality has shifted south. So that's why it's all fitting. It's happening right across, and it's not just here, it's happening in other countries as well, that poleward shift of that seasonality. But a key thing with farming is that successful agriculture occurs across all climate zones. So climate isn't necessarily, the be all and end all for successful farming. It has a big bearing on our seasons. And what's different about different climates and farming is that there's different ways that people manage their system to get the most out of it. And so I guess that's part of the challenge we have as some of these weather patterns shift south over the coming decade or two. Every now and then it'll nudge us into new territory, which will test our system. But if you look to your north, you'll see someone that's already farming successfully in a warmer and drier climate. So part of it is looking at, well, what are they doing differently and which bits of their system can I bring to apply to mine. And one key thing too, Sally, is that as we work our way through all of this, no individual's got the answer. It's all about connecting up and learning off one another. And that's the value of land care and being well connected. So you're doing all the right things. And there's heaps of great stuff happening in Northeast Big. I've got to hand it to you. There's really great awareness and great things happening on the ground to just, how do we grow more, make the most of the good years, and then manage your farms well for when things are really tight. These are the sort of recipes that we see right across agriculture, that even with perhaps a bit more challenging climate, there's strong demand, food and fibre. The world's needing plenty of it. But these are the sort of the key things that set us up pretty well with climate smart ingredients. And we've seen lots of improvements in genetics and new technologies and all of those things, which hold us in really good stead. And I was talking to an old forecaster the other day. He just said he's blown away by how good forecasting is compared to when he started his career. Just said it's amazing. And now farmers with their phone can check the radar, and we've got all of this stuff that would have been just a dream to have 40 or 50 years ago. So they're all good, and those things can be getting better. Improved on-farm and regional infrastructure is really critical. So whether that's to do with fodder storage or water storages or communications, all of those sort of things hold us in good stead. And often we learn a lot during droughts, and then when the seasons are good and we've got good cash flow, they're years to really think heavily about, well, how do we, what do we do to drought proof for next time? Really important, I guess one of the things that underpins a lot of our exports is good biosecurity. So part of the key message is we've still got to deal with any changes in climate, but we've got to keep doing the things we're good at, which is making sure we've got not good, clean produce that hasn't got some of those exotic diseases, because that's what keeps our markets open. So that biosecurity is really critical. Business management is so critical. We see as a bit of a theme across agriculture that when everything goes right, you can perhaps be more profitable than you've ever been before. But within sort of 2 years, you could have a season and you could have more red ink on the balance than you've ever seen before. So really, this business and financial management is a really key bit to how we manage this sort of fluctuation of seasons and markets. And that's, added to by the COVID situation. Great work by farm plans. And we see that people, Landcare's done a great job of just, protected waterways, good land class fencing, setting the farm up, avoiding overgrazing, having stock containment, good water storage, all of those things that have always made sense. They're just more important than ever to deal with, bigger fluctuations in seasons. And then the key thing is just connect yourself to good people, good advice, good networks. They're the things that, make life worth living. But it also means that when there's particular things going on, either good or challenging, you've got good sources of info that you can test your thinking with and work out, well, what do we do next? So I think you've got all of those things up that way in your part of the world, Sally, and your Landcare group and network does a brilliant job at that. So keep up the good work. I'm going to leave it there, and I can send you the copy of the slides if anyone wants it as well, but you've got the recording. So that's all good. Any questions? I'll shut up for a minute.
Oh, thanks, Graeme. I think you've given a fantastic summary of, well, certainly all of the tools and applications that AgVic has available. And there's a few in there that I didn't know about that I'll be keen to share with our group. I am happy to take questions. And while everyone thinks of something good to pop in the Q&A, I thought I'd open with one for you, Graeme. So I guess my question is, we're in a La Nina at the moment. So how long can that last? And what are the weather conditions that cause that phase or pattern to break up so that it sort of dissipates and we go back to a non-La Nina, or however you want to call it?
Yeah, good question, because it's the question on everyone's lips. And the analogy sometimes we use with these big oceans is they set up, and sometimes they have particular form and you can see it all happen, but then they go back and sort of reset. So the La Nina's on at the moment, but most of the modelling is expecting, through to the autumn and winter, it'll go back into the neutral zone. And all eyes then usually with a lot of these forecasts in the oceans, autumn's sort of often the least predictable time of the year. Not quite sure how those oceans are going to play up. And the timing of the autumn break usually is quite fickle. Like it's often driven by a weather event, not so much by, what those oceans are up to. So the La Nina will tail off and go back to neutral. And during sort of April, May, June, all of the weather forecasters are trying to have a look at, well, what's its plans for next winter and spring. And sometimes a La Nina can double up and have two in a row. But quite often they don't. And, usually every 10 years, there might be, a couple of La Ninas and there might be a couple of El Ninos. So, and a lot just sitting in the middle or just to one side. So there's no sort of bearing on that at the minute. What we make the analogy sometimes of our footy teams, whether you're a Demon supporter and Melbourne winning the flag last year in the AFL, or the Tigers fans, often everyone's hopeful in autumn, but you don't really get a good form guide for how your footy team's travelling until you get about to June, July, and you've seen how they've played, and has all of that early season chatter, has it actually performed on the ground? And it's a pretty good analogy for our oceans, both the Indian Ocean dipole and the Pacific Ocean. It really does take a while for it to reset, and then we get a bit of a heads up. If we're lucky, sometimes we can get an early read, and by May it's saying, no, I think both those oceans are looking to head in this direction. And then sometimes it keeps them guessing through the whole year where they say, what, we're not sure what they're going to do. So you're back to just sort of planning, have a plan for a drier, wetter or average, because the forecast's not really offering any clear guidance.
So for all those people that are thinking about early planting might be the go this year, you've just pretty much nailed it, that the autumn break's going to happen more to do with fronts than with this La Nina. And then we really don't know what's going to come from there. It's still very much to be decided. Yeah. So yeah, that's great. I mean,
some people, you've almost got, you could connect it all the way through if you do get some good rainfalls. But some of those March breaks that you might get up there, often they're from a big weather event that comes in, that it's not the start of the regular frontal activity. And so it's still really the hangover of the summer season, if that makes sense. So summer rainfall can be really handy, but often it's not as reliable. So sometimes part of the system, and we see it in the Mallee, farmers have been making great advantage of when they get a wet summer and they do their weed control and conserve that for the following winter. But you can't rely on it. It's sort of, you're never sure when it will turn up. Sometimes that's summer stuff. So just got to play it as it happens.
That's good. All right. Well, I've got two questions here, so we might work through both of those. So the first one was, with the different climate drivers, how reliable are they in terms of our rainfall and seasons for Northeast Victoria?
Yeah, they're probably, both of those, in terms of the Pacific Ocean and the Indian Ocean, both of them have their fingerprints over your seasons. If it was June and you were reading the break newsletter and they were saying, the models are thinking an El Nino and possibly an IOD positive is coming, you'd be, looking at that history there, you would say we've got, it really doubles the chance of being at the dry end of the scale. So you'd be wise to have a hand on the lever for a shorter spring. And also if they're at that wetter end. So it's as strong as anywhere in Victoria. That the challenge is it doesn't guarantee it. So what you might see is if there's a really strong forecast, they might say that there's 70 or 80% chance of wetter than average. And that's where you'd be looking at those deciles just to see, what is the chance of some of those dry deciles? Is it still there or is it really reduced? So they come in different strengths and shapes and sizes. And the years where we always try and, when we're talking with Dale about when we're more confident, it's usually when the models are having a year where they're saying, yep, we think the Pacific Ocean is going to head this way. And then as you watch it, the next month clicks over and you can see actually it has started shifting like they expected. You can start to see the cloud pattern forming. And when that's happening, then you see, that it's this year is a bit more predictable. But some years, the models might predict the ocean's going to do something. And then the next month or next 2 months or next 3 months, we're saying, well, you keep saying that, but it hasn't moved. And there are years which are saying, I'm not quite sure this year is going to be that predictable. So in my observation in the last 20 years, probably these seasonal drivers have probably been useful in about every 2 out of 3 years. And then every third year you get a year where you're saying, you know what, the forecast, they're not quite picking it up. So you're just best to, there's not a strong climate driver signal there. So you pretty much just, make decisions as, what rain you've had for the year, what you can see in the weather forecast, and then just have a plan, an A, B, and C. Because it's just not a strong signal every year. Wish it was, but it's just not the way it is. Just like your footy.
Yeah, well, that actually flows really nicely into our next question. So you just mentioned then that for probably 2 out of 3 years, those climate drivers are really, significant for our area. So the next question was, does the long-range climate modelling give indications as to whether those ocean currents and wind patterns may change or stop or reverse, fundamentally changing the importance of those climate drivers for our region moving forward?
Yeah, no, that's a really good question. So the big climate drivers, one of the big ones, I guess the cold fronts that whiz around the Southern Ocean, what they know is when you warm up the planet between, different ice ages and things, if you warm up the planet, the tropics expands either side of the equator. So you imagine that really hot, warm zone at the equator, it gets bigger. And then it tends to nudge all of the westerly winds further towards the poles. So what that means is if you see cold fronts slipping south a bit more often, that's to do with that sort of the world getting a bit warmer. And those winds sit somewhere between the warmest part of the planet and the coldest part of the planet. So some years the South Pole can be a bit colder than average, and it can drag some fronts further south, or it gets pushed south because of the extra heat. So it's one climate driver that is changing a bit, and they expect that to do that more often down the track. Still be variable from week to week, but that broader tracking, I heard one climate scientist talk about the roaring 40s, calling it the roaring 38s or something, is just to say that they're whizzing around. And what happens is that the big ocean current down there sort of gets driven a bit by the winds, which also means it changes a bit. And so what's interesting if you talk to a lot of our marine biologists is that some of that warmer water at the East Australian current coming down the east coast is tucking around the corner and getting closer down to Tassie, and warm water's turning up further. So it's partly driven because of those winds, and that current down south is a little bit further south. It allows some of that warmer water to poke down into, and some of the fish species that come with it to poke a bit further south than what they've seen. We see that too with climate zones and say bird species or some wildlife species, which often, different times, they just over time, their range might be heading south. The other one they've been working on, and it's still really unclear, things like the Indian Ocean Dipole and how the Pacific Ocean and the Indian Oceans, 90% of the extra heat at the moment is going into the ocean. So the oceans are absorbing it. And so it's just coming in there as a signal in our variability. But a key question some researchers are working on about, well, where might that extra heat sit? So an active question at the minute is, there's been a bit more heat that's sort of been sitting in the western part of the Indian Ocean. And some scientists have got a sort of a hypothesis that, well, if more heat starts sitting out in the western part of the Indian Ocean, it changes the ratio of IOD positive to negative years. And so I've heard someone sort of say, I think the millennium drought was just the fact that we had such a long run and we didn't have any of the wet Indian Ocean dipole years, because it was just we've loaded the dice a bit out there in the Indian Ocean, because the IOD negative was, negative in 2016 and a little bit again last year. And so that's an active question. I don't really know. So I guess the question is, well, what can we do about it? Well, by the time they've worked that out, we'll have probably farmed through another 20 years of seasonal variability. So we've just got to manage for the occasional surprise amongst the next sort of 20 years. So, and if you do that well, just manage for perhaps some increasing variability. That's what's under our control. Having good fodder, having good water, and then having good decisions so you don't do too much damage to your place. You're trying, when the season changes really quickly. So yeah, so stay in tune. I suspect there's quite a few surprises in store for us that, like I said, the climate change models get the direction of increasing temperatures. How hot depends on emissions and what 8 billion humans decide to do the next 30 years. Weather patterns move polewards, rainfall gets more intense, and droughts get hotter. So that sort of leads to a whole nother discussion there, Sally, which is around the whole emissions and carbon challenge, which we're all trying to make sense of. But that's driven by the physics in the atmosphere, which is pretty well explained. It was since the 1850s, I think they've known about all of that.
So I think what you've just said leads really nicely into a bit of a plug for some sessions coming up next week. So we've got Lachlan Campbell coming to Moyu next Monday night and to Tarrawingi next Wednesday night. And he's actually presenting some of the local climate modelling work that's been done in Northeast Victoria. So looking at different industries. So the Moyu session will be focusing on beef cattle farming. And their climate modelling that's been done it's down to sort of a 5K grid scale from what I understand. So we can actually start to look at some of those local changes in weather patterns and how that might impact stream flows and farm dam levels, rainfall, storm events. So if anyone's interested in coming to those sessions next Monday and next Wednesday, that'll be sort of the end of this little mini climate summer webinar event series that we're hosting. And we haven't got any further questions. So I'd just like to thank you, Graeme, for giving up your Monday night. It's been a terrific presentation. We have got this recorded and it will go online so that everyone can watch it again. And I think you explained some really difficult topics, with the southern annular mode and all the ocean drivers in a really easy to understand way. So thank you very much. Sending you a jar. We usually give all our presenters a jar of honey or something as a thank you. So doing that virtually to Geelong. But thanks very much. And look, everyone, if you've got specific questions for Graeme, I can share an email address and I'm sure you can email them through. Yeah. And thank you again. That's great. And enjoy your night, everybody. Thank you. Bye-bye.